Hello everyone. Good morning. I am Mr. Dakshinamurthy, Assistant Professor, Department of Artificial Intelligence and Machine Learning. I am handling subject 22 CS 302, Computer Organization and Architecture, Unit 2, Arithmetic Operations. Topic Computer Data Representation. Outline of this topic is computer data representation, mainly classifying into two types: fixed point numbers and floating point representation, and basic computer data types. We are going to discuss from this topic. Basic computer data types. There are two basic data types implemented in the computer system: fixed point numbers, floating point numbers. A representation of such data types is called fixed point representation and floating point representation. Fixed point representation. The fixed point or integer numbers are represented in two forms: signed integers and unsigned integer. Unsigned integer number represent positive numbers range 0 to 255. Signed magnitude representation range minus 127 to plus 127. Here we are using ones complement and twos complement techniques. Fixed point representation, the leftmost bit, sign bit in the binary number represents a sign of the number. Sign magnitude format for 8-bit signed number. For example, decimal plus 8 for positive values, sign bit is 0 and the remaining magnitude bit is in the place of 0, 0, 0, 1, 0, 0, 0. We are using binary weightage we are giving for each bit. For the first bit we are giving 2 power 0, second binary weightage 2 power 1, 2 power 2, 2 power 3. In the place of 2 power 3 we are having 1. That means 2 power 3 is the binary weightage. Multiplied with the 1, we are getting 8. Similarly, for the negative number representation, the sign bit value, least significant bit value is 1. Floating point representation. Very large integer and very small fractions. A computer must be able to represent numbers and operate on them in such a way that the position of the binary point is variable and is automatically adjusted as computation proceeds. In this case, the binary numbers is set to float and the numbers are called floating point numbers. The floating point representation has three fields: sign, significant digits, and exponent. The floating point representation, let us to consider the number 111.101.0000110 represented in the floating point format. To represent the above number is floating point number. First binary point is shifted to right of the first bit and the number is multiplied by correct scaling factor to get the same value. The number should be in the normalized form and is given as 111.01.1000110. It is represented 1.1110110 into 2 to the power 5. Here the after decimal point value which is given as significant bits, whereas it is a binary representation. The base value is scaling factor and the exponent value considered as exponent. The floating point representation, it is important that the base in the scaling factor is fixed to 2 because this one is binary representation. The string of the significant digits is commonly known as mantissa. Here 111101 dot 1000110. Here 1.1110110 into 2 power 5 representation. Here significant bits after decimal point, whichever given is significant digits. The base value is scaling factor, exponent value which is 2 to the power 5. Pi is the exponent. In the above example, we can say that sine equal to 1, mantissa equal to 1110110001110, exponent is 5. IEEE standard for floating point numbers. There are two types of IEEE standard. One is 32-bit standard, single precision representation, and second is 64-bit standard, double precision representation. A single precision representation, 32-bit word, the field 1 sine equal to 1 bit. Field 2 exponent is 8 bits. Field 3 mantissa is 23 bits. The picture which depicted for the single precision, we are having around 32 bits, in which most significant bit is sine bit, and then the least significant portion where we are using mantissa, and then second portion is exponent, the mid portion. We are having 8 bits for exponent, which can be represented maximum minus 127 to plus 127. Instead of the sine exponent e, the value actually stored in the exponent field is e dash equal to the e of the scaling factor plus bias 127. Here bias is 127, so it is known as excess minus 127 format. Example, represent 1259.125 base 10 in the single precision and double precision formats. Solution, convert decimal numbers into binary. Then we are getting 10011101011 for 1259 decimal value. For 0.125, for that we are getting 0.001. The binary number which brought from the 1259.125 is 10011011011.001. After normalizing it into the sine bit and the significant bit and scaling factor exponent like this, mantissa into the base value, that is scaling factor power exponent value, we are getting. Single precision representation, here s is equal to 0 because the given number is positive, e is equal to 10 exponent, m is equal to mantissa, that means 00 111 01 001. Bias for a single precision format equal to 127, e dash equal to e plus 127. Here exponent value is 10 plus 127 is 137, that is binary equivalent value is 10001 base 2. The number in single precision format